Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. In this episode, we will talk about the advantages of standardizing and automating protection testing practices. The life cycles of intelligent electronic devices, or IEDs, used in protection systems are becoming shorter. The time spans between firmware updates for these devices are also decreasing. Electrical utilities need to verify several parameters more frequently, such as the functional requirements, the quality of new firmware, the correctness of commissioning, the parameter settings, and more. Therefore, the need for qualified testing strategies is becoming more essential in each phase of the life cycle of protection devices. Joining me to discuss this trend and to share a new protection testing approach is OMICRON protection testing expert Michael Albert. He will describe how standardization and automation can improve testing quality and decrease testing time. He will also provide us with best practice examples for implementation. Hello, Michael. Welcome to Energy Talks.
Hi, Scott. It's a pleasure for me to be with you here in the Energy Talks.
Thank you again for being here for this discussion. Michael, could you please briefly explain how protection testing has become more and more of a challenge for electrical utility companies?
Yes, I can try to do it briefly. So I think there are some technical challenges and some organizational challenges. Let's start with the technical ones. I think there are a lot of new technology waiting for the people. So that means the complexity of the protection devices have increased in the last years and will increase. And also the firmware updates. That means that I think the normal cycle was a few years in the past where you have to use new firmwares, and the IEDs will now increase. So we have yearly updates perhaps. So therefore a lot of work is waiting for the people there. And on the other side, the organizational things are that the people have less and less time to do their job there in the substation, to do the testing job. And it's that they have really problems, the utilities, to find the right people. So they're missing the stuff. They have problems with knowledge management. So that's are the main things, I think, very briefly.
Okay, thank you. What would you identify as factors that need to be considered now and into the future?
The main things is that there's no way back. So that means it will not be like it was in the past. So we have to face the challenges we have, as summarized the question before. And I think the world is also getting faster and faster. That means the development cycles in the industry, they are getting shorter and shorter. And therefore, the work is increasing for the people in the field. And also the energy demand is also increasing in the world. And regarding the climate crisis, the electrical energy demand will increase more than an average. So that means all the challenges will remain, and we have to find some ways to master them. And let's change the way of testing as part of that changing.
Okay. What are or will be specific testing challenges faced by electrical utilities throughout the life cycle of protection IEDs?
As I said before, there will be more work in general in the field of protection. So, and also with this technology, the new technologies and the firmware updates, there will be a need for more protection testing. And regarding the changes in the grid, we will have a lot of renewables all over the world installed in the next, I would say, 10 to 20 years. New generation of IEDs with new functionalities and so on. So that the most important things we have to change is that we have less time, less stuff, and more work.
Michael, how are these challenges driving the need for standardizing protection IED tests?
So we have a lot of tasks to do in the future. And it seems to be that one possibility is that we have to change our work and the workflow in the field of protection testing. I try to give you an easy example. So it's a little bit off topic, but 30 years ago, if you want to make a phone call, you take your notebook where you have listed all the phone numbers and you put it in the telephone and you start the phone call by ringing somebody and talk. Today, you have your mobile with you, with everything is inside, and you just press one button and you can make a phone call. But in the end, you will chat, and that's something to do with new technology. And that means we have now facing new things in the field of protection testing, and we should use new tools and not the old phone from the past.
Good point. What are the key advantages of standardizing these tests?
So once you have standardized protection testing, then you get directly the advantages here. So you will get reproducible results out of the protection testing. So every tester can do the same test with the same quality at the same time. So that means there's no need to check what happens in the field. You can also ask the colleague in the team, say, okay, I have problems here with test 21, and everybody knows test 21 is one of these standardized tests, and everybody knows the tests are comparable. So therefore, with a good documentation, which is also a part of standardizing, you can connect protection testing into internal processes. And this is an important part of quality management today.
Interesting. Michael, what exactly is meant by test standardization for protection IEDs?
In the example before, we talked about everybody is doing the same test. Therefore, is a need that you have at the beginning of a standardizing process, you have to define what you want to test it. For example, for a routine test. So you're going to test the main protection function. You are going to test the environment. Just write down what you want to do. And then in the second step, and this is the main part now, you take this document where you have written down what to test, and you go through this document and define for every step how it's done. And in the end, you have really the specification of a standardized test, and everybody knows what to do. And then you can easily test your device, and you have every time the same quality ensured.
Great. Well, then, how do you know that the test specifications are working to standardize the process?
That's really a good question at this point. Mainly, it's a personal experience I have made in the past. So I work in this field for over 15 years now, and I always work together with customers, standardization of tests, developing test plans, and so on. And independent of the size of the utility, once you have started standardizing your tests, you never went back. They all stuck to this solution, and they integrate it in their workflow. They use it day by day, and it's really improved their workflow there. They never go back to manual testing or individual testing, I would say. But in the regard of quality and the performance of a test, it's not easy to measure.
Interesting. But speaking of which, one way is through key performance indicators. How do key performance indicators, or KPIs, play a role in measuring success of testing standardization?
This is perhaps a possibility to make this progress. So the progress of changing from, I would say, individual manual testing to modern automatic standardized testing, to make this progress visible. You can compare the before, the old version of testing, to the new technology. I try to give you perhaps an example or two. So let's speak about test coverage. Test coverage, perhaps a short explanation, means just you say, okay, I have 30 parameters which are changing from feeder to feeder, and I want to ensure that these parameters are tested. And if all parameters are well tested, you can say, okay, you have a test coverage of 100%. What we are doing, we're doing the right things. That means effectivity. And you can also introduce as a KPI, and of course, if you do manual individual testing in the right way, you're doing the right things manually, it has the same quality as do it in an automated way, of course. And then for the second step, you introduce a KPI for the performance. So for the time you spend for preparation of the test and running the test. And then if you introduce this KPI, then you're going to measure the efficiency. So that means doing the right things correctly. And then this leads directly to say, okay, if I can improve my performance by a factor of 3, 5, 4, it depends a little bit on the task you have to do, then it goes directly to test automation.
Okay. Michael, once you have confirmed that you have the right specifications in place to standardize testing, what comes next?
As I said before, efficiency leads to automated tests. Now you have to take the specification and try to make it efficient. That means you have to introduce test automation. And for this, you have to find the right level of automation. So if your task is you have two devices, for example, generator protection is not so often in the field like line protection devices. And if you have only 2 or 3 of these protection devices, then it may be efficient to have easy automation. It means not every parameter is adapted directly as a test plan, which is prepared, which solves the problems, and it's not fully automated, I would say. Not everything is adapted directly. If you have 500 of similar protection devices in the field, then you invest a little bit more in the automated solution, and then afterwards you get a higher level of automation, a little bit more as in the preparation of this test, but in the end it pays off because the preparation of the number 2 to 500 are going to be 0. And then it's of course depending on the people involved. So how many people are using this solution? Is it only one guy, so he can do whatever he wants, he knows what to do? Are there 30 people, 50 people involved? Then of course you have to invest a little bit more in this solution. And at the latest point, if it's going to realization, then you have to check the tools, which tools you have. If you have, for example, the solution from OMICRON with really good automation capability, or do you only have a solution where you have limited possibilities to automate? And then you have to decide which level of automation is the best for my company.
How do we then really automate the testing process to ensure greatest efficiency and reliability?
Scott, that's really a nice question to say greatest. So there will not be the one and only greatest solution, but I think it's always where to start. If you introduce this automated testing process just to the overall company, or do you just automate or standardize just one part of it? For example, the life cycle of an IED starts in the factory or at the manufacturer side, but normally a factory acceptance test is a good point just to start here. Then you have the commissioning, then you have perhaps routine tests every 3-5 years, and so on. And if you just pick out the maintenance testing part, you have the efficiency only working in this phase of the life cycle. But if you start at the FAT, for example, you do this standardization at the beginning of the life cycle, you can profit from this work in the following stages, so that you are using parts of the factory acceptance test doing commissioning. Of course, you have to add something here for having a proper commissioning. And another subset of this will be the routine test afterwards. So therefore, it's not to say there's the greatest solution. This will be a great solution if you introduce it. And the earlier you put it in your testing process, the better it will be.
Michael, when successful, what benefits can standardized and automated protection testing mean for the future?
I think beside all the advantages we have talking about before, it's just the future challenges we have. So if you have this automated standardized process in the field of protection testing, you can easily adapt future changes. So that means introducing new technology. For example, if the new technology will be introduced at the FAT, not be really new technology, it's just only a new generation of protection devices. And you can solve all these things during this phase and can hand over it to the people. So that means that's some kind of a knowledge management which you can use here. And you can solve technical issues at the beginning and not solve the technical issue at every protection device in the field again and again.
Michael, why do you see standardized and automated protection testing a necessity for electrical utilities?
If you look at the challenges and the benefits, I think it's more or less obvious that it's a big step forward for the utilities. But we have the training of new people in the company. So this knowledge management topic, I think this standardizing means well-documented protection testing process means that you can take them to new people and they have easily access to the solutions they have to use in the field. And therefore, I think this is a big part. If you look at the problems, the utilities have to find the right people, to hire people in general. I think this is a necessity for the utilities at this point. And the technical example is always the same. Inventing the wheel again and again. So that means developing the solution in front of a protection device in the field makes no sense.
Michael, to summarize, what can protection testing engineers be doing now to adopt this concept? Is it already something that electrical utilities can implement?
Starting just with the first part of the question. So the testing engineer itself should have no fear for new things. So that means taking the mobile phone example, So everybody is using it right now. And if we do not want to have this solution, we would always have to look for a telephone to give a call. And the new things will come, driven by the protection device itself or the new technology. So they should try to be open-minded for other solutions, so that they say, okay, we change the technology in the field and we also change the way of testing the use of the tools. And they should be keen on learning the new things. That's very important. And they should not think that standardization and automation means that the team size will be reduced. So in the end, the utilities did not find any people, so why should they fire them? So this is not a threat for them. And the teamwork itself, it will be quite easy by using this solution. From the utility point of view, they have a lot of possibilities here. So they can change their quality management, they can solve the problems with the time pressure, and they can start to improve the life cycle management itself. Standardization, they can start for themselves. It depends on the people they have. If they have good engineers, so we have this example in the past, they're really keen on doing this standardization work, and they really can have a look 10 years in the future what that means if they do the right things right now. I think it's not a problem.
How can OMICRON assist with this transition?
We can share our knowledge. So if the utility has not the right people in place or not the possibility to give this space to do this work, so we can support with our knowledge. We can explain the technicians how to use our tools. If once the decision is made, we want to have it. So we can also help to train the people, and we can show the solutions we have. And by the way, let's check the tools from OMICRON. So we offer the right tools to do this. So we have a really good test devices, the CMC fleet with all the accessories around with a good quality. And then we have the software tools fitting to this problem. That means Test Universe and also really SimTest together with all the automation capabilities. So, and the people working for OMICRON. So we have a lot of people. We have teams which are able to give the answers. So for example, we have a team which develops for over 15 years now the protection testing library, which we offer on our website for the customer. There are over 400 templates for protection devices. Different protection devices are available. And we have this knowledge of all these devices in the company, and we are ready to share. Just ask us.
Michael, thank you very much for sharing your insights into this topic about protection testing, standardization, and automation in this episode of Energy Talks.
Thank you. It was a pleasure for me, and you're welcome.
And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. OMICRON has several years of experience in power system testing and offers you the matching solution for your application. This includes protection testing, which was the subject of this episode. For more information, be sure to visit our website at omicronenergy.com. Here, you will also find information about upcoming webinars and training courses offered by OMICRON Academy on a wide variety of power system testing topics. Also be sure to check out our event calendar for upcoming opportunities in your region to meet with us in person. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.